There are three acid-base theories that we're going to look at, and they differ in how they define acids and bases. First of all, acids, present in a number of things, from food, carbonated drinks, to batteries, and so forth. They will taste sour. Bases are found mainly in commercial products, cleaning supplies, soap, and they will taste bitter. The first definition is the Arrhenius acid-base definition. Arrhenius acids are hydrogen-containing compounds, and they will ionize in solution. They will produce hydrogen or hydronium, H3O+. Bases contain the hydroxide group, the OH- group. There are monoprotic, diprotic, and triprotic acids, differing in the number of ionizable hydrogen. Monoprotic has 1 ionizable hydrogen, diprotic has 2, triprotic have 3 ionizable hydrogen. Notice though, with all of these acids, hydrogen is written first. Normally, if hydrogen is written first, it's an acid. Not all compounds that contain hydrogen are acids. The hydrogen have to be ionizable. For example, in HCl, because this is a polar bond, chlorine is slightly negative because it's more electronegative, and hydrogen is slightly positive, this hydrogen is ionizable. When you put it in water, water breaks the bond and hydrogen gets freed. That's what ionizable means. In CH4, the hydrogen is not ionizable because CH4 is a nonpolar bond. There's a small difference in electronegativity between carbon and hydrogen, so this particular compound does not contain ionizable hydrogen. So CH4 is not an acid. But again, if you see hydrogen listed first, more than likely it is an acid. The Arrhenius bases contain hydroxide, OH- group, and hydroxides are formed when you react elements in group 1A with water. So for example, if I take sodium and react it with water, I will get a base. I will get NaOH, and I will release hydrogen gas. So that is how we form bases. Here's a couple of examples of some Arrhenius reactions. In the first one, HCl, that's my acid. It contains hydrogen listed first. LiOH, that's my base. It contains the hydroxide group. Arrhenius reactions produce a salt and water. Now, a salt is a generic term for a cation plus an anion combined into a compound. In the second example, CuOH2, that's my base. It's got the hydroxide. H2SO4, it's got hydrogen listed first. That's my acid. You see I get water and salts, CuSO4. The second acid-base definition is Bronsted-Lowry. Acids lose a hydrogen, bases gain a hydrogen in the course of a reaction. So for example, NH3 plus water, forming NH4 and OH. Okay, acids lose a hydrogen. Notice how water goes from H2O to OH. Water loses a hydrogen. So in this case, water is an acid. NH3 goes from NH3 to NH4. In that process, it gains a hydrogen, so NH3 is the base. With Bronsted-Lowry, we also have what are called conjugate acids and bases, and conjugates appear on the product side. A conjugate acid is formed when the base accepts a hydrogen, and a base is the particle that remains when the acid loses a hydrogen. So let me give you another example. In this equation right here, first of all, HCl goes from HCl to Cl-, so it loses a hydrogen, so that means HCl is the acid. Water goes from H2O to H3O, picks up a hydrogen. Water is a base in this reaction. On the product side, we have my conjugates. H3O and H2O go together. H3O is the conjugate acid of H2O. And Cl- and HCl go together. Cl- is the conjugate base of HCl. And if I reverse this reaction, Cl- would gain a hydrogen from this side to this side, and so it would be the base. Water is amphoteric. It can act as either an acid or a base. If you look in these previous two examples, in the first one, water was an acid. In this one, water is a base. It depends on what it's reacting with. The third acid-base theory, Lewis acids and bases. A Lewis acid is an electron pair acceptor, and a base is an electron pair donor. Here's an example. If a reaction does not fall under the Arrhenius or Bronsted-Lowry, it's probably Lewis. In this example here, it's not Arrhenius, it doesn't have H and OH. It's not Bronsted-Lowry, it doesn't have the hydrogen transfer, so it's Lewis. And in order to determine the acid and the base, I need to draw the Lewis structures with the valence electrons. Cl has 7 valence electrons, 7 dots. And aluminum only has 3. So that's what the structure looks like. Cl-, the minus means you add a valence, so instead of 7 it has 8. Acids are the electron pair acceptor. Acids want electrons. Notice how aluminum has an extra spot for an electron pair. So AlCl3 is my acid. It wants the electron pair. Cl- has an extra electron pair. It's the donor, it's the base in this reaction. So with Lewis acids and bases, you draw the structures. And then in this case, AlCl4 is just a salt. So here's a summary of the 3 types, Arrhenius, Bronsted, Lowry, and Lewis. And again, they differ in how they define acids and bases.